just a small correction. I'm actually not a contributor to Sandstorm. I've just been following the project closely. I was asked by them if I would care to turn some of my knowledge of their project into a paper, so I did. I made a best effort to be accurate. It's possible there are bugs and that they will, rain fury down on me, but I did run the paper past them and they signed off on all of it. So anyway, take everything with at least a little grain of salt. Okay, so as was said, Sandstorm is a new approach to web application hosting. So I'll go into some details about that in just a moment. But if you pay attention to only one slide, read this one in its entirety. I will just basically read it out loud. Sandstorm is a capability-based design for hosting web applications. And it enables, fundamentally, this capability design enables very, very, very fine-grained encapsulation of web applications. It turns out that that encapsulation can, in many cases, completely obviate concern about LangSec problems. So yes, you can run programs that have path traversals, or you can have run programs that have buffer overflows. And it turns out, in many cases, it no longer matters. Right? That's an interesting premise. The flip side of that is that applications still have to pay attention to authorization. We'll see in a little bit that Sandstorm takes care of a great deal of authorization within its framework, but applications still have to care, right? Is this request valid? Should I execute this request? Capability systems offer a perspective, or the Sandstorm design in particular offers a perspective where the question, is this request authorized, is a question of parsing. And therefore, LangSec is actually relevant to a maybe new part of the computational job, right? The computational task. We no longer care necessarily about are we never going to look at the wrong file under client input, but we do care about are we going to sign off on a mutation request for someone who isn't authorized to mutate. Anyway, the parser now turns out to be the right place for validating authorization. Okay, so let's go through this in some more detail. How many people have stood up? But just to say, if you have a question, just chime in with it. How many people have ever stood up a web server? Right, basically everybody, yeah, right. How much fun was it? Yeah, right, maybe the first. Okay, so if you've ever stood up a multi-user, multi-application web server, there you put many applications on the same machine. They lived side by side each other in the file system. When they ran, maybe there was UID-based isolation between them, right? Maybe you had a kernel user created per web application, and Apache sued over to that user while it was running. The system design encourages ambient authority, right? The contents of /bin are world readable. The contents of /etc very largely world readable, right? Network access typically unrestricted, right? Just by virtue of running on the system, you gain the ability to make TCP connections. So we call this ambient authority. Just by existing, you have the right to do something. If there's a database involved, right, there's typically one database involved for the whole server, one database process for the whole server. It has its own notion of users, but users, again, really mean applications. So if your applications are juggling multiple users, those are getting mapped down just like they were with the kernel. They're being mapped to one kernel user. They're also being mapped to one database user. So these permission systems aren't going to help you within an application. Authentication and authorization questions, abbreviated authn and authz, sorry, are left up to each application. Right? When you go to log in, or when you go to use an application, you have to authenticate to each application in turn. Your ACLs, or your rights within an application, are managed within that application. There's no crosstalk. There's been some development in recent years to have single sign-on systems, but curiously, all of those require buy-in from the applications. And so your single sign-on systems start to look less like single sign-on because that program doesn't support it, whereas that one does. Right? This is a sad story, right? How we got here is Markovian and time-based, but it's still sad. Oh yeah, and one last thing I forgot. The web was never intended to be what it is being used as now, right? It was a way of shipping informational content. It wasn't designed as an application substrate. So there are these things like cross-site request forgeries and cross-site scripting attacks, sub-resource integrity, and all of these things are big concerns for web applications, and every application has to address them over and over and over. This is no way to run a show. So in this environment, right, when I say it's no way to run a show, what happens when there are LangSec style bugs in this world? Well, the simplest thing is that you can have outright confusion about authentication or authorization. Right? Somebody leaks a cookie via some debug channel, and suddenly I can impersonate a user, right? Or I can craft cross-site requests, right, which are intrinsically LangSec problems, right? You somehow were able to fabricate a byte string that caused an action to be taken even though you didn't have rights to perform that action. Path traversals, huge problem. If you can convince a given application to engage in path traversal for you, right, read an arbitrary file from the file system, well, almost surely it will read any file that is part of that application. So if you have a shared document host with other users, you can read any of those users' documents. Likely you have access, or maybe you have access to other applications on the web server if you're not doing UID isolation or if you have incorrectly UID isolated them. And you, again, very likely have access to system configuration. So if you're running, say, a Tor hidden service and there's a path traversal, right, well, someone can dump your network configuration and completely de-anonymize the machine. Right? So LangSec bugs are anywhere from minor nuisances to completely catastrophic in this world. And of course, there's also code injection, or sorry, path traversals. Now there's also code injection, right, where the parser is not only misparsing, but is, you know, overflowing buffers and all of that bad stuff. Once you can run code on the machine, all of the ambient authority of the web application becomes part of your attacking arsenal. Right? You can probe the local file system arbitrarily. You can mutate files if you can, right? You can make loopback connections. Sometimes those are more privileged just by fiat. You can make remote network connections, so you can use a compromised machine as a springboard. You can probe the local kernel for vulnerabilities, right? This is bad. Right? Hopefully everyone agrees that there's just like reason after reason that the current state is bad. So what are we going to do? What does Sandstorm do in particular? Sandstorm replaces the web server with an application supervisor. It's actually very much like a kernel. You could maybe argue that it should be a kernel. It is not a web application firewall, for those of you who know the term, right? Sandstorm does not sit between, in a content way, does not sit between an application and a client. It simply routes display content through it. The big changes that we make to the framework, we're going to centralize authentication, right? We're going to make the supervisor aware of users. And the supervisor will tell an application which user is using them, right? This guy named Nathaniel is making this request. We're also going to, but that's kind of been done with SSO. We're also going to centralize authorization to the supervisor. So an application is going to say, users that use me have some subset of these rights, you know, read, write, mute, you know, administrate. And the supervisor will manage what rights a user has to each application. Every request that goes to the application will be paired with the rights that that user has. Having done that, we will find, and I'm going to skip a bunch of the steps, I'll go back to them. Having done that, we will find that we can sandbox our applications very, very tightly. In many cases, we will be able to sandbox an individual document. We will be able to put that in a container process. And the upshot of that is, if you have access to that application, you have access only to that document, nothing more. That includes if you have code injection attacks against that application. Doesn't buy you anything. All right, so to recap, the old world, right, you put on your administrator credentials and you install the web server and the applications to that web server. You had users register with each application. The application did a lot of work internally to juggle multiple objects, rights to those objects, and also tracked internally what the rights of users were. In this new world, right, we only have to put on our admin credentials once to install the Sandstorm server. After that, users can install arbitrary applications. At any moment, any user of your system can install any code that they want without needing privileges. Users register once with this core instead of once with every application. And then the users will instantiate applications. They will say, I want a new document of that kind, or I want a new wiki of that engine. These grains begin as private to the creator. Then, when the user has set up the application the way that they want, they will share access to that with other agents through the Sandstorm supervisor. So what this looks like from a user's perspective, here's Sandstorm running on one of my machines back at Hopkins. It looks kind of like an app store. Right? That's weird. Web servers don't usually look like app stores, do they? So to give an example, if I want to make a new tech document to share with people, I will bring up the Share LaTeX page, and you can see that I have already have a grain of Share LaTeX started. That is, in fact, the paper for this conference. And if I want a new one, I just click the Create New. So when I've got my document up and running, so this frame is managed by the Sandstorm core. The application itself is essentially unmodified. It's providing some HTML back to Sandstorm and says, please show this to the user. Sandstorm forwards it on to me. Once that's ready to be shared, I ask Sandstorm to please grant read and write access, in this case, to other people. I can actually send them email through the system, or I can just grab a URL. The URL looks like that. If you were to go to that, if you're feeling ambitious, you can type that in. You don't have to. Right? If you were to go to that, you would actually get read-write access to this document. If you, I see some people copying down slides. I should have put a QR code up. So you will get read-write access to this grain. And if you register with that instance of Sandstorm, that will become associated with your user account. So what's going on within this kernel? The supervisor is tracking capabilities of writes to grains. So I said before that each application tells Sandstorm what writes means. So for Share LaTeX, it's really simple. Right? It's just one document, and you can either read it or you can read and write it. It's a very straightforward access model. The DocuWiki port, for example, has a couple more, or slightly more fine-grained access. There are users of the wiki, there are managers of the wiki, and there are administrators. Users can read and write existing stuff. Managers, I think, can delete pages, and administrators, I forget what they can do. But the point is, relatively simple delineation of rights. When a grain is created, the creator gets all of the rights, and no one else gets anything by default. Right? So everything starts off private. Then users delegate rights, delegate access to the grain. So that is to say, they create a new capability object, one of those new URLs, that gets turned into some database rows internally. They are able to delegate any subset of any access that they have. So if I've created something, I can give out read access to this half of the room and read-write access to that half of the room. The really fun thing is anyone then in this half of the room can cause their read access to be given to somebody else too. Right? Delegation is a transitive move in this system. Right? You guys, if you had read-write access, could give write access to anyone to act on your behalf. The kernel keeps track of provenance of all of these things. So if someone over here shares with someone, I get to see that that has taken place. And if I don't like that, I can actually go and revoke permissions. And I can say, no, right, I didn't mean to give this half of the room read-write access. I meant to give you read only. And anything that you have delegated also loses that write access. Yeah?
Can you remove access from a tertiary, from somebody you shared with? Removing the access?
Without removing the access to the initial one. That should be possible. I don't know off the top of my head. Thank you. Yeah, we would have to ask them. Yeah. So this actually, there's a fine tangent we could go into about capability theory and confused deputies. For humans, Sandstorm actually draws a distinction between humans and non-human agents. For humans, your rights merge. So if you are sitting in the middle of the room and you have read access from over here and read-write access from over there, if I revoke all of that, you still maintain your read access. You as a human don't have to juggle multiple capabilities. You maintain the union of all of your rights. Good question. So while the supervisor is running, what it's doing is it's juggling sessions. Right? So every user that's connected to a grain is a session. The grains are spun up and spun down as needed. Right? So we don't have daemons running for every document that's ever been created on this server. It's only the ones that are actively in use. And the neat trick is that at session startup, the grain is told what rights are attached to that session. So all the application has to do in order to ensure that authorization takes place is it just needs to check that a request is within the rights conveyed by this session. Right? There's no complicated internal database of users and permissions. It's just this session is allowed to write. This is a request that is a write request that's permitted. Because Sandstorm's in a good position as a supervisor, it can actually deploy some defenses against web attacks, web-specific attacks. So every session gets thrown onto a random hostname, big, long, unguessable string. This helps against cross-site request forgery and cross-site scripting attacks. OK, within a grain, and here's the meat of the mitigating LangSec problems. Within a grain, there's relatively little there. The file system, which is constructed as a private namespace, contains only the application code, mapped read-only, and the grain's data, mapped read-write. Right? Then there's a minimal collection of like device nodes and binaries that you have to run the system. All of that's read-write. You can't make more device nodes. You're completely cut off as a grain from the native network. It's just not there. And the system call vocabulary is dramatically filtered down. Right? Some 100 or so of the system calls are just prohibited. So how do you actually communicate in that world? Well, the supervisor, which execs the grain, simply carries a socket to the supervisor along with it, right, across exec. So all communication to the outside world goes through the Sandstorm core. And it goes over a cap and proto RPC mechanism. So the Sandstorm supervisor really is acting like the kernel. It's the way that this grain can interact with the outside world. So Sandstorm claims on their website that 95% of application CVEs were mitigated before they were discovered. This is actually borne out by the data. It's their sample, not mine. So there are 20 CVEs that they collected during some period for a couple of the applications that had been ported. Share LaTeX, Tiny RSS, WordPress, Roundcube. it turns out that of these 20, only one of them is not mitigated by these architectural changes. Turns out you can actually smuggle an XSS in through Roundcube. Oops, right? The bugs are still real. But 19 out of 20 no longer matter. Right? All 4 of the path traversal vulnerabilities no longer buy an attacker anything. Because in order to engage them, you had to have access to this thing anyway. Right? Okay, you can read out the document to which you can already read. Right? Code injection bugs tended to require write access or were in applications that tended not to be shared. So again, doesn't really buy you anything, right? You can attack your own service. You can load code onto a server that you could already load code onto. Go ahead.
What does this do about, say, phishing attacks, though? Because you have XSS and you can attack
Oh,
users.
sorry, none of this is to say that it completely obviates it, right? Indeed, the XSS that survives is in an email application. It's in Roundcube. So you could potentially get someone to engage in or to be phished, right? You should absolutely not stop writing software with LangSec in mind, right? You should still be filtering the display content. It's just that think of this as a safety net, right? This is an architecturally induced safety net. If you miss, maybe it's not so bad. Does that answer the question?
Yeah.
Cool. Also on that list, there were authentication and authorization vulnerabilities that are just not a concern anymore because all of that's moved to the supervisor. And they looked at only a subset of the Linux kernel CVEs during the same period. There were a lot of them, 224 of them. The 27 that they looked at, 24 were completely mitigated by the system call filtering. So they just didn't apply. The remaining 3, yeah, they were bad, right? Bugs are still bugs, but reducing the number from 27 to 3 is pretty good. Okay, so just to expound on that previous point, all of this is just a safety net, right? It doesn't solve the problem. It's still possible to have bad authorization checks in an application, right? Just because Sandstorm told a grain, this user only has read access, and then the user fabricates a write request, right? The application could say, oh, sure, right? That's fine, run it anyway. No, we have to stop that. It also is true that a counter argument to this is, yes, share LaTeX, it's fine to silo an individual document, right? That's perfect, it's sort of a natural boundary. Maybe there are applications where you can't so neatly encapsulate, right? In which case, LangSec bugs are still problems, right? You have a bunch of resources all collected together. You can trick an application into revealing a resource that it shouldn't. But only within the silo, so maybe it's not so bad. So the hope is that this approach, this new system architecture, rules out or at least confines damage from certain classes of bugs. Hopefully it makes it easier to write secure software, right? That's what we're really all about. And while we're at it, it provides a new slogan, a new direction, new tack for LangSec. It opens the door for authorization to become a parsing question. So just like parsers traditionally imbue data with trust, is I think the line, right? Now they can imbue data with authorization. And with that, I'll take questions.